Welcome to SHANAS AI Technologies, advanced course on embedding artificial intelligence and machine learning within Oracle Cloud EPM. In this session, we'll explore how Oracle's platform leverages cutting-edge data science to modernize corporate planning, forecasting, and reporting. Whether you're a consultant, architect, or finance leader, this guide will help you transition from manual, spreadsheet-heavy processes to automated, data-driven systems. We'll break down the underlying architecture, configuration steps, and deployment workflows for Oracle's built-in AI capabilities. Let's start by reviewing the structural pillars that form Oracle's cloud-based performance management framework. Throughout this course, we'll cover the essential topics needed to master AI and machine learning in Oracle Cloud EPM. You'll gain insights into the overall architecture, user roles, and the technical workflows that drive automation and efficiency. We'll also discuss how these technologies can transform your organization's planning and reporting processes. By the end, you'll understand how to implement, configure, and optimize Oracle's AI-powered features for maximum business value. In planning an AI deployment in Oracle Cloud EPM, it's crucial to address the needs of two main user groups. On one side, EPM cloud power users and business analysts focus on leveraging embedded AI tools to accelerate and optimize business processes. They use system predictions to validate planning assumptions and uncover market trends, all without needing deep data science expertise. On the other side, EPM cloud system administrators handle technical configurations, mapping machine learning variables, and deploying automated rule schedules. Balancing both roles ensures a smooth and successful rollout. In this overall course, we shall cover in 3 sessions. In this session 1, we shall cover Oracle EPM AI functional architecture, business strategy and value drivers, predictive planning architecture, predictive planning step-by-step operation, predictive planning technical value, auto-predictive planning deep dive, auto-predictive planning job lifecycle, core predictive use case architecture, predictive cash forecasting core engine and its workflow. Session 2 topics are EPM Insights Architectural Framework, Bring Your Own Machine Learning BYOML Architectural Core, PMML File Standards and Specifications, Touchless Operations Engine Core, Auto Text Summary Function Pipeline, Narrative Reporting Performance Mapping, Conversational AI Platform Architecture, Anatomy of an ODA Skill. Session 3 topics are Oracle Modern Best Practices OMBP Overview, Budget to Approval Workflow Mapping, Report to Forecast Workflow Mapping, Key Performance Indicators KPIs Matrix, BioML Model Ingest and Deploying Groovy Logic, Interacting with AI Forecasts, ODA Conversational Setup, Technical Troubleshooting and Guardrails, Implementation Roadmap and Resources. In planning an AI deployment in Oracle Cloud EPM, your implementation strategy must address 2 primary user groups. On the left, we map out the needs of EPM cloud power users and business analysts. These users focus on leveraging embedded AI tools to accelerate and optimize everyday business processes. They rely on system predictions to validate their planning assumptions and spot hidden market trends without needing a degree in data science. On the other side, EPM cloud system administrators handle technical configurations, mapping machine learning variables, and deploying automated rule schedules. Balancing both roles ensures a smooth and successful rollout. Oracle's embedded AI features are divided into 3 distinct functional pillars. First, data-driven predictions use machine learning to build statistical baselines that support strategic decision-making. This pillar includes predictive planning, auto-predictive planning, predictive cash forecasting, IPM insights, and bring your own machine learning workflows. Second, touchless operations focus on speed and efficiency by using generative AI to write automated performance summaries within narrative reporting modules. The third, digital assistance, uses deep learning for natural language conversations, allowing users to interact with enterprise data seamlessly. Deploying AI within Oracle Cloud EPM delivers clear financial and operational advantages. It replaces subjective, instinct-based budgeting with rigorous, auditable statistical calculations. It shortens close cycles by using automated text engines to draft narrative commentaries. Automated text engines shorten close cycles by drafting narrative commentaries, while anomaly detection features protect liquidity by flagging cash flow risks before they become critical. Ultimately, these tools empower FP&A teams to deliver data-driven insights that enhance strategic planning and boost corporate credibility. Let's take a closer look at our first major engine, predictive planning. This core feature parses historical data using time series forecasting algorithms to generate clear statistical projections. Instead of relying on simple year-over-year additions, it maps out a clear processing pipeline. The system extracts historical records, applies time series equations, generates baseline scenarios, and lets users write those values directly back into active corporate forecasts. The predictive planning execution pipeline follows a clear 5-step path. First, the data analysis engine scans historical database intersections to isolate repeating seasonal variations. Second, it applies statistical forecasting equations over those clean historical data lines. Third, the system generates predictions and displays them in interactive charts and data tables. Fourth, corporate planners compare their active plan assumptions against these statistical targets to check for realism. Fifth, users run direct copy commands to move the system-derived predictions into active forecast layers. Understand the value of predictive planning, we must contrast it with traditional forecasting limitations. Legacy forecasting often suffers from human bias or relies on flat percentage adjustments that miss broader cyclical shifts. In contrast, Oracle's predictive engine delivers objective, mathematically sound baselines that help organizations navigate volatile market conditions with confidence. Auto-predictive planning takes automation a step further by processing high-volume calculations across entire data cubes. Administrators can configure the engine to automatically build and write out 3 distinct prediction slices. The base case slice represents the most likely operational path. The best case slice defines the upper performance limits for optimistic planning. The worst case slice models downside risks to support contingency planning. Auto-predictive planning job lifecycle relies on a structured 5-stage administrative process. First, the administrator defines the prediction by selecting a historical source cube and defining the analysis timeline. Second, they specify the target slices for base, best, and worst case scenarios. Third, they schedule the job using the EPM automation engine. Fourth, the system processes thousands of data intersections simultaneously during off-peak hours. Fifth, the calculated results are written directly to selected forecast members for immediate business use. Core strengths of the auto-predictive engine are parallel processing power, rapid forecasting speed, and structural flexibility. Unlike basic data forms that calculate one row at a time, this engine updates thousands of cells simultaneously across large member slices. It gives planners a robust statistical starting point on day 1 of a cycle, reducing manual effort and highlighting major variances in real time. Predictive planning engines can be deployed across a variety of real-world corporate use cases. In finance, they model future revenue lines and operational expense items based on historical trends. In treasury, they predict cash flow changes by evaluating receipts and disbursement records. For supply chain teams, they estimate product demand across channels, while also projecting returns on marketing and capital investments. Now let's examine predictive cash forecasting. This specialized machine learning engine unifies treasury data across the enterprise to automate short, medium, and long-term cash flow projections. The platform integrates ledger records from core ERP systems, cash positions from treasury management systems, and corporate spending goals from planning applications to build a unified view of organizational liquidity. Cash forecasting engine includes several built-in tools for proactive liquidity management. It builds continuous daily, weekly, and monthly rolling forecasts. It lets users assign unique statistical models to different types of cash lines. It supports what-if scenario modeling to test strategic shifts, includes anomaly detection features to protect against cash shortfalls, and unifies treasury teams within a shared workspace. The operational workflow of the cash engine follows 4 clear steps. First, the data sourcing tool connects to internal applications to pull transaction data that impacts cash balances. Second, machine learning algorithms scan historical flows to uncover hidden payment patterns. Third, the system generates rolling cash forecasts across operations, financing, and investments. Fourth, finance teams review the dashboards to track liquidity risks and secure short-term funding when shortfalls are predicted. Thanks for watching. We shall stop here. In subsequent sessions we shall discuss about below topics. A PM Insights Architectural Framework. Bring your own machine learning. BYOML, Architectural Core, PMML File Standards and Specifications, Touchless Operations Engine Core, Auto Text Summary Function Pipeline Narrative Reporting Performance, Mapping Conversational AI Platform Architecture, Anatomy of an ODA Skill. Please subscribe to our YouTube channel for more such videos.